Good evening. It's Saturday, I think, something like November the 4th. And I wanted to slip in it's going to be kind of a brief uh, little video on grading a cut slope. Uh, you will have finished your midterm by the time you get here. But I really don't think there's anything on that midterm that would be taken from here. Uh, I'll check that out. If it is, just make a note of it, and we won't count it if you don't know it or if we didn't cover it. But I believe most of this stuff has been covered. I'll probably put up an announcement telling you to watch uh, this video prior to the midterm. But again, I really don't think you'll have any problems with understanding the cut slope. You do know we went through building a fill slope. This is how you would start on a level, well, not necessarily level ground, but on existing grade, and stair step going away from us and coming toward us. And I'll talk about that in just a minute. It starts out though by talking about I don't think they call it anymore this way, angle of repose. Uh, that was referring to, if you recall, perhaps in your trench safety classes, if you've had some, I think we touched on it in one or two here, uh, that 1.5 to 1 is Class C soil, and Class C soil is a coarse grained soil, so it can't be very vertical. Uh, an angle of repose is where the earth will settle uh, naturally if it's not solid rock or caliche or something like that. You can see the little picture where it's at 1.5 to 1, and that's just at rest. Repose means at rest. So starts out talking about a grade checker. You will be working with soils, and you should know some of the characteristics of the material you will be working with, such as how much space you need to pile dirt, or estimating the amount of gravel to crush rock that's in a pile. Soil has a definite slope when heaped in a pile, and this slope is called the angle of repose, and it's the maximum angle at which soil will lie without sliding. It won't completely flatten out on its own. The angle of repose or natural fall of ordinary earth is approximately 1.5 to 1, and they show you a little picture of that. So it goes into talking about why we're talking about that. Fill slopes are engineered for a 1.5 to 1 slope or flatter. 1.5 to 1, as you see above there, is a pretty steep slope, especially for a dozer, and absolutely too steep for a motor grader or anything on rubber tires. So the so flatter would be a 3 to 1, a 4 to 1, a 2 to 1 would be flatter than a 1.5 to 1. But think about this: there's reasons that we want our slopes on the side of the highway to be as steep as we can without causing problems for mowing operations, for instance, and so that the earth won't flake off, erode before the soil, before vegetation takes hold. And another thing is, if you recall the formulas for the slope ratio of horizontal divided by vertical gives you the slope. You will recall that if you know the vertical of a, let's say, 2 to 1 slope, if you go back to your circles or your brain or just remember the formula, you take the vertical, multiply it by the slope ratio, and I think I said 2, and say we have a vertical of 10 feet. Well, our horizontal is going to be 20 foot. In other words, this is 1.5. We would be on a 2 to 1. This thing would go out like this, stair step. But if it was like a cut of 10 feet, our horizontal for that slope would be 20 feet out here. So instead of taking up 1.5 feet, we would be taking up 20 feet of right of way. So the steeper of the slopes on each side of the highway, the narrower the right of way you have to purchase to build the highway. That's another reason. And not having to move the earth is still yet another reason. Some of the roads you see in mountainous areas going through granite or rock or something like that are just dang near 1-to-1, straight up and down. And some of them have to have, I forget what they call it, wires or something to hold, loose rock from falling down and things like that. So we're going to go through some steps here. Uh, and I'm not spending that much time on slopes just because we've already covered them. So this is going to tell you kind of what are the things you need to do. And let me catch up with some of this highlighted stuff. So into steep slopes such as 1-in-1, because material won't stand on a much deeper 1-in-1 is just like way straight. In grading a cut slope, you start with the same first steps that you used to build a field slope. If you recall those are that deal where you want to get rid of the oddballs, like the highest multiple of 4 that can be subtracted from your total fill. If you recall that, we'll be doing a little bit of that as a brush up. So you start with the same first steps, like setting the first step, only you'll be going down like this as we go along. So let's see. It's just like going up. During the operation, it's necessary that you continually check the grade, in this case, down when you're doing a cut slope, down from the top, and inform the dozer operator by hand signals how much material is left to be removed. Because see, this ground that this guy's standing on was all like all out in here, and they came in and they got it close, but he's taken this natural ground and he's cutting stair steps in it just to keep this a little bit shorter video here. You can probably read and understand this, but it says in building a field slope, after we had raised it up about 5 feet, we would set our first stake. Well, here, once you've lowered it about 5, you want your dozer to finish grade this upper part so you can start staking for him down here, because he's going to continue to take lifts out. Usually you think of a lift as putting in, but he's going to make as deep a cut as he can each pass here. See, he's coming toward us here and he's going away from us now. And this is a slope board. And this is when he's taken the steps out that he left, as he'll start finishing right here and it'll be clean. It won't be stair step like that. It'll just be a straight line once he takes those steps out of there. Hope I'm not going too fast. I kind of feel like I am, but bear with me, and maybe the literature will catch up with us here. During the operator, it'll be necessary for you to continue to check from the top down, because you got to build a cut slope from the top down. No way around that. So let's move on a little bit. When he's finishing staking up here, if you recall, this is the reference stake, the offset stake or the information stake that tells you where to put your top stake and your hub. So this guy's getting that top stake out of the way of the slope board. So when he's done finishing that, he can reestablish elevation at the top. So let's see how they describe that. By pulling out the top lefts and laying them down on the top of the slope and pointing to the hub where it is, because he probably covered it up when you finish, you will save them from being destroyed during this operation. They will also be in the right place for you to pick up and hold at the hub to show the dozer operator using the slope board where the hub is. so the dozer operator can see the location of the hub and know how much to cut. After the top of the cut is finished to slope grade, you will replace each top lath at this proper location. I don't know why I insist on reading all this, but I don't have a shortcut right now. You will need, because these things I'm reading to you are what's going to be on your test. You will need to establish grade or a hike up on the lath and tie the correct cut. Now we're beginning to stake going down, and tie the correct color flagging. White would be for a 1 foot boot, and they're calling it a hike up. Red is a 2 foot boot. Red and white's a 3 foot. Yellow is a 4 foot, and the yellow and white's a 5 foot. Just for reminding you. At the elevation where you want it. In this case, you would want to leave a 1 foot boot as we go down, and we'll get into that specifics as we get on down here. And since we're talking about a 1.5, 2-to-1 slope, you will be a 1.5 or 2-to-1. You will be dealing with dimensions in the following ratio. 1.5 to 1 foot vertical is the same as 3 to 2, as 4.5 to 3, and those are really not necessary for you to know right now. Need to know. They're talking about the relationship, what a 1.5 slope is compared to is like a 4.5 to 3, and those are things we don't need to get into right now. So where it's practical, you will want to use a 6 foot horizontal to a 4 foot vertical. Okay, now they're talking about this stuff right here. These horizontals and these verticals. And I think these are 6 feet. And that's the oddball up here. So we'll wait till we get to that. Let us assume that there's a cut of 15.3. This is the example we're about to get into. And it's a 1.5 to 1 slope. Since you intend to place the stake rows down 4 feet from the preceding ones, you will use the greatest multiple of 4 that can be subtracted from the cut of 15.3. 15.3 greatest multiple of 4 is 12, so that leaves you with 3. A 3 1/10 vertical distance. Right here, if I'm reading, let me get my glasses off. Make sure that's 12. The print's kind of, yeah, 12 subtracted from 15.3 leaves 3 1/10. So this right here, if you can't see it, is 3 1/10. Now I know right here it's saying, I'm sorry, not 3 1/10. It's 3 3/10 because that's a 15 3/10. You take 12, you get 3 3/10. I'm sorry. So this right here, this is just illustrating the 1.5 to 1 slope. This is what we're dealing with. So the vertical is 3 3/10. If the vertical is 3 3/10 and we're dealing with a 1.5 to 1 slope, then our horizontal is going to be 3 3/10. That's our vertical times 1.5. Let me do that. 1.5 times 3.3. That should be 4.95 right here. I'm not sure. This is 3 3/10 right here. If you multiply right here, they multiplied 1.5, the ratio, times the vertical of 3 3/10, and that leaves you 4 9600. Now they call that something else up here, 9 5/10 or 9 and 50, but it's 4. It's where did it go? Where did it go? It's right here, 4.95, which is 4 95 hundredths after we multiplied 3.3 and 3/10 times 1.5 ratio, we get 4 95 hundredths. Now the rest of them, of these verticals, are going to be 4 feet. Just to refresh your memory, and I don't want you to pay attention. This is 4 95 hundredths. It's not anything else, and you don't. It is really 4 feet, and it's 9/10 and it's 5 hundredths. It's 4 95 hundredths. So during the time that you're placing the first stake row, the first stake row would be this row. And remember, we're going away from us and toward us when we're building this thing. During that time, excavating the area down below you, the dozer will be brought back to grade the slope. And that's what he's doing right here. He's already graded himself through these stair steps down to this grade. And if you look closely, you can see that what he's doing, he's cutting out a notch that's probably uh, his like 1 foot, because that's the one. You know, these things are 1.5 to 1, et cetera, et cetera. So that's the one, and he's moves over 1.5 feet each time. Or he can't cut a 4-foot vertical. That's too much dirt to cut at a given time. So these things just have to be stair step down over and over again until this slope turns into whatever they want it to be. And in this case, it's one and a half horizontal and down 1. So 1.5 feet over, down 1. Really, you'd be under the ground doing that. Each time the dozer grades the slope, it would be necessary for you to shoot grade. So here's the top cut. It says cut 15/3 at 1.5 to 1. And we have determined that we're going to be down for this stake 3 3/10, and that means we're going to be 4.4 95 hundredths horizontally. So we go downhill, stick the stake in the ground, and then we will shoot from here back to here, and we'll pull this grade over to here, and then we will measure down 3 3/10 and put our mark there, and that's where our grade will be. See, it's different from going up the slope. You had to shoot it and then measure it up. This one would be, you come down and you get behind the stake, and you want this grade right here. So you would aim at the grade mark, the top of the hub. And when you were level, you would mark your stake, and then by definition, on this first one, you would measure down 3 3/10. And if it was just a little above, you would have to cut. But if not, if you're on grade, you don't do nothing. But your earthwork would either be to fill or to cut to get it on grade, to get it 3 3/10 down. So first stake row, you shoot back to your hub at the top stake, put your mark there, and measure down whatever this is. From this point on, it's going to be, what is that, 5, I think, because 1.5 times 4 is 5, right? And yes, I will get the calculator out. Messed up. 5, 6, I'm sorry, I said 5. It is a 6 now that I look at it. I think it is a 6 now that I look at it. Yes, 6. All of our horizontals are 6 because all of our verticals are now, well, this is 3.3. So hold on. Yeah, yeah, it has to be 6 because our vertical next is going to be 4. And then our 4 times, we'll make that 6, I think. 4 times 1.5, that's multiplying the vertical times the slope ratio, and that equals 6. So all of these will be horizontals from here on out will be 4 vertical, 6 horizontal, 4 vertical, 6 horizontal. So that's hopefully we'll get some time to stake a slope on our in-person and show you how to do it. Here's what you might want to make note of. I know this kind of stuff is on the test. Just the steps that we just went over is I think mostly what's on that thing. May ask you to calculate one of these deals. Just remember your circles and your your formula. If you Here it is up here. This is another chance. This is just pertaining to this problem right here, but it does tell you how to make a circle. So get that on a piece of paper. It's just a surefire way of doing it. Use a calculator, you know. So in our case, we knew the vertical and we knew the ratio, and that's where we got this first stake at 4/9500ths. And so once we did that, all the rest of the stakes were going to be coming out at 4 down times 1.5 to get 6. 4 down times 1.5 gives us 6. So use that. Go through these right here. This some of this stuff will be kind of on the it'd be on the test and jumbled up, and it's kind of got to locate the offset stake. You got to clear and grub before you can do anything, and then relays cut information by hand after slope has been brought down far enough. That's 5 foot, they called it a while ago. And here's where you would feel using 4 foot, each stake would have a cut, 16 more cut of this because it's what was left for the whole thing. The whole thing was 15.3, believe, and then we took 12, so you got 12 coming down, so it would be cut 16 because we got that first one out of the way, cut 12, cut 8, and cut 4 would take. Remember those exercises we did where we're going up the stake? This is the same thing going down. Okay, bring the dozer back. Let's see. This is using the slope board, and in here, in doing this, he's taken these I wish I could visualize these little slots. Like you can see a slot here. Well, you can see he's down a little bit here and he's on top of it. But he would take this cut all the way over here to approximately where this toe of the slope would be horizontal, which would be 15, 12 or whatever it was times 1.5. And that's how far he would go, because by the time he reached that, he would have his slope built, and then he would come back through. And if it's not too steep, you can cut these stair steps out with your blade. Otherwise, they have a slope blade. And I've used those once. It's kind of awkward, but you get used to them. They're pretty heavy. So any questions, give me a call or inbox or something like that. But I don't know if you needed this video. It's probably understandable, but I thought I'd throw it up there. And you guys have a good rest of the weekend. and be sure and go over the other modules to get ready for your midterm. Well, actually, you've already had it by the time you see this video. I've already gone through that. Well, I'm going to shut the video down.